Hello, I'm back with the first part of the 2016 Oxford PAT. So this will be the maths questions. Still got 2 hours. They're still splitting it. Maths first, physics second. We got 11 maths questions this time. Still no calculators. Yeah, nothing's changed from previous years. So let's just move on. So differentiate this expression. So we're going to do product rule on this. So f dash of x is going to be, so leave one, differentiate the other essentially. So we're going to get sine of x squared, and then we're going to add the, what's it going to be, 2x multiplied by x and then cos x squared. So yeah, that's what we're going to get on all of that. So it's a nice, you can see it was only 2 marks. That was a nice easy starter. Find all values of theta between 0 and 2 pi which satisfy this equation. Right, I think get rid of this root 3 and then complete the square. So we've got tan squared theta minus 2 over root 3 tan theta minus 1 equals 0. So tan theta minus 1 over 3 root 3 all squared, which means we're going to have to take off a third and then take off 1 is equal to 0. So tan theta is going to be equal to, that's going to be 2 over root 3, and then we've got, well, plus or minus, and then we've got to add a root 3 on all of that. So that is going to be 3 over root 3 or minus, well, let's put the root 3's on top because that also helps. But yeah, we got 3 over root 3, which is root 3, or we've got minus 1 over root 3. So minus, actually 1 over root 3 is talking the language of tan. So let's leave it like that then. So yeah, so that's going to be our 30 degrees and our 60 degrees, or minus, actually it's minus 30 degrees next we've got minus root 3. So let's do the root 3 one first because that's easier, because we're going to have pi by 3 and then we just add on pi each time for tan. So that's that one. And then the other one is going to be going back 30 degrees. So going back pi by 6. So it will be 11 pi over 6. And then take a pi off. So 5 pi over 6. Right, okay. So yeah, not too bad, but you kind of have to work a little bit for that, which is probably why they got the 5 marks on it. Oh, logs. Right, great. We do like a bit of logs. So this is going to be what we got on all of this. So the top one, we're going to have, that's going to be log base 4 of 64 to the power x. So that is going to be 3x. And then the bottom one will be 2y that we have to take off. So that's just redoing the top equation. And then we've got the x plus y equals 1. Right, okay, they're not expecting much here, are they? So 2x plus 2y equals 2. So x equals 3, which would make y minus 2. 5 marks for that. I mean, that is just, well, yeah, what can you say? Anyway, take it. What's the term independent of x in that expansion? Oh, I don't like that very much. Right, so how are we going to get, so independent, if we've got 12 of them, we're going to have 8 on the first one. So we're going to have 8 x to the 8 multiplied by 1 over x squared to the 4. So we need to do that split. So how are we going to end up? There's only 1's in it. So all we need to do is find the choose number. So either we've got to go through, because this is what we want. We want the 4th one. I mean, that's the same as the 8th one. It doesn't matter whether we do that or that. It's the same thing. So we want to get one of those. So we can go for, well, it's n factorial over r factorial n minus r factorial, if I remember that right. But we could work this out. So how are we going to pick? We've got to choose 4 things from 12. Let's just make sure I've got this formula right, because I don't always remember this. So we're picking 4 things from 12. So that means we're going to have 12 times 11 times 10 times 9. That's how we're going to pick those four things, but we don't care about what order they're in. So we need to do that divided by the 1 times 2 times 3 times 4. So yeah, 1 times 2 times 3 times 4. So that's what we're actually working out. Yeah, which is going to be this, because that's our r factorial at the bottom. And we've got an n factorial, but we've taken off the 8 factorial at the bottom. So yeah, that is correct. But this is what we're trying to work out all in all. So that's fine. We can get rid of those to get rid of that. And then we can get rid of that to make it a 5. So we've got 5 times 99, which is equal to 495. So actually, it's better to talk through it than it is to use the formula. But yeah, it's nice to be able to remember that formula sometimes. And it also gives you the option, if you did care about the order, then you've got that many more permutations. But that's fine. Otherwise, if you're not going to do anything with that, you've got to work your way through Pascal's triangle up to level 12. But you only need to go in, 5 numbers. So you don't have to do the full triangle. You can just work your way towards that. But I'd recommend either remembering the formula or, even better, understanding where it comes from, because it's not that complicated as demonstrated in that little description there. How many numbers greater than 5,000 may be formed using some or all of those digits, but without repetition? How many numbers greater than 5,000? Right, so if we're using all of them, then it's anything. So for 5 digits, then it's any number that we can get from these. So that is going to be 5 times 4 times 3 times 2 times 1, which is going to be, 120, isn't it? 6 times 20, yeah. So we've got 120 off of those. If we've got 4 digits, then we need to start with 5, 6, or 7. And then we're all right after that. So that will be 3 times, because you can only pick one of those. So we've got 3 options for the first one. But then times 4 times 3 times 2 times 1. So that's 9. What have I got there? 12 times 6, I should say, which is 72. So that leaves us with 192. Okay, that was fine. An interesting question, that one. Something a little bit differently. So not doing the, tossing a coin thing all the time or rolling dice. A seed is planted. After 1 month, there is 1 twig containing 2 leaves. 1 twig, 2 leaves. In the following month, the twig grows 2 further twigs, each new twig containing 2 leaves. Right, so we started with that, and then we go to that. And this keeps on happening until we get to month 10. So that's 1, 2. So, and what do we want? We want twigs or leaves? No leaves drop off. How many leaves? So we want leaves. So we're going from 2 to 6. What we're going to have after the 3rd month, we're going to be adding on another, but we're going to get 2 times 4 onto that. So that'll become 14. And then we're going to have 4 times 4. So we'll add on 16. Yeah, okay, this is add on 16 makes 30. So yeah, we're going up by 4, 8, 16, 32. So we'll end up with 62. So that's, that's leaves. We are working out leaves, aren't we? So after 10 months on all of this, what are we getting? This is, yeah, what are we doing? So that is trying to see what we're actually working out here. So yeah, 2, then 6, then, so yeah, adding on, I'm just struggling to see exactly what the sequence is on all of this. We're getting powers of 2. Yeah, for twigs, it's 1 less than a power of 2, isn't it? That's what we're looking at. 1, 3, 7, yeah, 15. And then, yeah, 31. So twigs is going to be equal to what we got, 2 to the n minus 1. Is that right? Yes. So we're going to have, and then we need to double that for the number of leaves. So we've got 2 to the n plus 1 minus 2 is leaves. Right, so that's fine. And we've got n is 10. So we want 2 to the 11 minus 2. Wait a minute, I'm trying to think. So 2 to the 10, I know is the 1024. So that's going to be 2048 minus 2. So 2046. Right, that's the power of 2 that I always end up remembering. The 2 to the 10 is the 1024. There's something about that 10 and the 10 there that just makes it so much easier to remember. It's the one where you cross 1,000. So keeping that in mind certainly helps. Now what we got? Dice game. All right, we've got another probability one now with dice. Player throws a fair 6-sided dice n times. To win the game, he needs to throw the following exact sequence with the n throws. So he needs to go 6, 5, 4, 3, 3, 3, 3, 2, 2, 1. What's the probability that he will win if he rolls the dice 8 times? I mean, his chances here are pretty low. Oh, that's why they're saying leave your answer in terms of powers. Well, if he rolls the dice 8 times, you ain't going to get very far because there's 10 numbers. So probability equals 0. Need at least 10 rolls. You might as well put that at least 10 rolls. Might as well mention that. 10 throws. So that's fine. B, so 10 times means he needs to get it exactly every time. So that's going to be 1 over 6 to the power of 10. Yeah, right. And then 12 times. So you've got 2 more throws that can come in. So you've either got, what have you got? So, all right, so we can either do 2 more at the end or 2 more at the start or 1 at either end. So you've got 3 more options. So it's going to be 3 over 6 to the 10, because you could start your sequence on first, second, or third throw, and then it's the same chance of actually getting the sequence then. So we're 3 times up. Okay, so yeah, so far so good. That's 7 of them done. I mean, we've only got, what is it, 4 more to go in this section. What we got now? We got compare a regular octagon with a circle of radius r. The distance between 2 parallel sides of the octagon. Okay, right. So just got a picture. What should x be in terms of r if the 2 shapes have the same area? So we've obviously got our pi r squared there. How are we going to get this area of the octagon? Don't fancy splitting it into triangles, because the angles on the triangles are going to be unpleasant, aren't they? Because 36 would have 360 divided by 8, which is going to be a mess. So we don't really want to do that. Yeah, because that, actually, would that come out all right? Actually, that might not come out too badly, actually, because we'd have 45 degree angles. 45 times 8 is 360. So we could do that. That is a possibility, isn't it? But then, but then we'll be doing half of the, no, I don't like that actually, because then you'd have to, if we were doing that triangle and you had a 45 degree angle there, you'd then split it into 22.5. So yeah, we'd end up with stupid angles we don't want. So I don't want to split it into triangles. So let's go with making it a square, taking off those corners. So if we add that, so this is going to be x squared minus the 4 triangles. So how are we going to work out these triangles? We need to get the length of a side. So side length is going to be, how are we going to work that out? How are we going to work out side length? So we've got, let's say it was y. these are all 45 degrees. So that's going to be y root 2 over 2. So we're going to have y plus root 2, side length y, and y1 plus root 2 will be the width, is x. So that's good. So I can't even remember what I'm trying to do now. So the area is, what are we getting? Oh, right. So actually these 4 triangles are going to be y squared, aren't they? Because, yeah, we can just extend, we extend one of these out. That is 4 triangles. So we want x squared minus y squared is going to be that. Okay. So the area, so pi r squared, because we're saying these things are the same, is going to be x squared minus y squared, which is x squared minus x squared over 1 plus root 2 squared. And now we can just get that as x in terms of r. Right, so I'll scroll down and try and figure all of this out. So what's 1 plus root 2 squared? That is, and I'll factorize the x squared actually. So we've got 1 minus 1 over, so it'll be 3 plus 2 root 2. Yeah, 3 plus 2 root 2. Okay, so we've got that. That's going to be, let's sort out that bracket then. So 1 minus 1 over 3 plus 2 root 2 is equal to, so 3 plus 2 root 2 minus 1 is 2 plus 2 root 2 over 3 plus 2 root 2. So then rationalize the denominator, which is going to give us that. So what have we got? At the bottom, we're going to have 9 minus 8. Oh, that's handy. So that just disappears altogether. And at the top, we've got, what have we got? We've got 6 minus 8 plus 3 root 2 minus, no, plus 6 root 2 minus 4 root 2. So that's plus 2 root 2. So that is equal to 2 root 2 minus 2. Right, that's good. So what has that left us with then? So we've got that pi r squared is equal to x squared times, well, let's take the 2 out, and then 1 minus, no, root 2, sorry, minus 1. God, root 2 minus 1. Right, that's grand. So we just need to rearrange that for our x. So we've got x squared is equal to pi r squared over 2 root 2 minus 1. So we want to rationalize that with a root 2 plus 1, root 2 plus 1, which at the bottom is going to give us, so that would be 2 minus 1 is 2, well, multiplied by that 2 there. So we've got 2 at the bottom. So all in all, we've got that it's pi r squared root 2 plus 1 over 2, giving us that x is just the square root of that. So r square root of pi root 2 plus 1 over 2. Put a big root sign. There we go. It wasn't too bad. Yeah, once you sort of get into it, and it's all about spotting that you can turn it into a square. Otherwise, you might be in trouble trying to work that one out. That's one of the tougher geometry ones. That might be the most difficult one they've had so far, I think, in all the papers. So question 9, we just got to solve this inequality. Okay, so we've got for x is greater than 0, greater than equal to 0, we've got that 5x minus 3x squared is less than 2. For x is less than 0, we've got 5x minus 3x squared is greater than 2. So let's set up our quadratic then. So we'll have 3x squared minus 5x plus 2 equals 0. We'll get the roots on this. Is that going to factorize? Yeah, I think it will. Let's just have a look. So if we were doing that, we'd have to have the 2 on that side, the 1 there, and 2 minus is minus 2 minus 3. Yeah, that works out fine. So we got our roots at x equals 1 or x equals 2/3. So this is our quadratic then. So that's at 2/3, that's at 1. We need what are we trying to solve? So when x is less than 0, we want this to be less than 0. So on this side, well, we've got no solutions over here. So that doesn't work. And if we're on this side, when x is greater than 0, we want it to be greater than. So we need to have x is between, is it actually greater than? Yes, it needs to be between, well, it can be equal to 0. It needs to be between 0 and 2/3, including the 0. And, or x has to be greater than 1. Okay, that's all fine and hunky-dory. Obviously, people have very different methods for working out those inequalities, so you might not be doing the same as me on that one. Find the area of the region enclosed between the following curves and including the origin. Well, these curves don't look particularly intimidating, so this should be easy enough to visualize. Let's draw in. So if we got a 2 minus x and a 2 plus x, so they're both going to go through, we've got that one, which is going to go through minus 2 and 2. You're going to have the opposite going like that. That's going to be a straight line going through there. And then we've got an x squared minus 4. Oh, so that's going to go through these points as well. Okay. So we've got all of that going on. Which region do we want again? They're enclosed by all of them. So what's that going to mean? Let's change over to red so we can see. So if it's enclosed by all of them, that's going to have to be, yeah, it's going to have to be this bit, isn't it? Because, yeah, otherwise we're getting outside. Yeah, we can't include those bits because we're getting outside of one of the lines. So working that out, we want the area of that. So that area is going to be equal to, well, we've got this square of 2 by 2 because we've got these two triangles. So we need 4 plus the magnitude of the integral from minus 2 to 2. Actually, let's go from 0 to 2 and double it, because that is going to be the same. This is symmetrical, of x squared, minus 4, not plus 4. Right, so what is that integral then? So that's going to be 4 plus the magnitude of 2. So we've got x cubed over 3 minus 4x from 0 to 2, which is 4 plus 2 lots of, we got 8 over 3 minus 8. Right, so we're taking the magnitude of that. So that is going to be 4 plus, well, we can switch it around and make it positive. So it would be 2 times 8 minus 8 over 3. So what is that going to be? 8 minus 8 over 3 is 16 over 3, 32 over 3 when you double it. So that's 10 and 2/3 plus 4, 14 and 2/3. Okay, so brings us on to question 11, which is the last one in the maths section. Cylinder of dough is squashed such that its height h decreases linearly with time in that fashion. For t is less than h0 over alpha. Okay, so we're not getting negative height. Assume that the volume v remains constant, retains a cylindrical shape. Okay. Find an expression for the rate of change of the radius of the cylinder as a function of time. Right, interesting. Right, so we need to say something about the volume. So anyway, let's write all these things down. So we've got h. I'm just writing out that thing again, just to, so it's with everything else. So that's what we got for h. We've also got the volume is going to be, have they said anything about an r? They haven't said anything about an r, but let's put it in that it's pi r squared h. It's something that we know about a cylinder, so it can't do any harm saying what that is. So we can do, what are we after? We're after getting the rate of change. Oh yeah, so we do want, so I've mentioned r here. So we want rate of change of cylinder as a function of time. So we want dr dt. We've got h as a function of t. So we're going to want to convert things around. Right, okay. So that means that dh dt is equal to minus alpha. We want to get dr dt. So dr dt is going to be dr dh dt. We've just got dh dt. We can, oh, the volume's fixed. Oh, that's good. So yeah, this is going to help. So we can do dr dh with all of this. Or we can do dh dr, might be even easier. So we've got the h is v over pi times r to the minus 2. I'm putting it as r to the minus 2 because it'd be easier to then differentiate it. So dh dr is going to be equal to minus 2v over pi r to the minus 3, which means that dr dh is equal to 1 over dh dr. So we're going to get pi r cubed over 2v, and we've got the minus sign. Right, where is this left, everyone? So this leaves me with dr dt is equal to dr dh, which is minus pi r cubed over 2v, multiplied by dh dt. All right, multiplied by minus alpha. Right, okay, so that's not too bad. So that gets rid of the minus signs. Is that it? What have we? Oh, we got it in terms of R. We want to get, right, yeah, we need to get it in H0, alpha and V. We've got alpha and V, so we've got to get rid of this R then. So, but we've got R in terms of H. So if we've got R in terms of H, we can then, and we've got H in terms of T. Oh, this is a mess, isn't it? Right, so that is equal to, anyway, so what are we left with? We've got alpha times pi times r cubed over 2v, and we need to get rid of this r. So we're saying that r is equal to the square root of v divided by pi times h. Okay, h is h0 minus alpha t, square root of v and pi h0 minus alpha t. So r cubed is going to be equal to v over pi h0 minus alpha t to the 3 over 2. Right, that seems okay. Have we got anything else left in this? I'm not sure. I think that's going to be, I think that'll be all right, because yeah, they want it in terms of just h0, alpha and v. So when we get rid of this r cubed, we've got alpha and v, and then h0, alpha and v. So yeah, all I have to do is put that in. So we've now got that dr dt is equal to alpha pi over 2v multiplied by v over pi h0 minus alpha t to the 3 over 2. Is there anything I really want to do with that? I suppose you could neaten it up a bit. Obviously, you'd lay this out much more neatly if you were doing this in an exam. I'm having to scatter across the screen because I have to work sideways as much as up and down. Yeah, let's tidy it up a little bit then, because we've got these pi's and v's that we can do some cancelling with. So what are we going to have for pi's on all of this? The pi will have a v left at the top. If you put all this in a square root is what I'm thinking. The alpha over 2 stands alone. We put it all in a square root, then we're going to be left with a v at the top and a pi at the bottom. And then we're going to have this thing cubed. h0 minus alpha t is going to be cubed, because that's going to leave us with a, yeah, 3 over 2 for that thing at the bottom. We got a root v, because we got a v to the 3 over 2 and then take 1 off, leaves us with a half, which is why it's at the top. And we got a pi to the minus 3 over 2, add 1 on, which leaves us with a minus a half. So yeah, that works. So that is our dr dt. That was a tough finish, that one. That was by far, I would say, the most difficult question out of all of these. I suppose the geometry one was quite hard. I mean, it was fine if you could see that you turn the octagon into a square, but otherwise it was fairly tricky. That was a tough finish for 6 marks. I mean, you can see the amount of working out we've had to do. If only they could have just said, oh yeah, leave it there as a function of left R in there as one of the options, but no, you've got to get rid of the R's and replace everything with all these constants. So just have it as a function of time. Yeah, there you go. I mean, it wasn't the most remarkable set of questions. They weren't that easy. They weren't that hard. There wasn't anything that was massively interesting in them. It was just a sort of meh bunch. But let's see. I mean, the physics ones are always the ones we're here for. They're the more interesting questions. You know, people are applying for physics, they're not applying for maths. So hopefully we'll have some interesting stuff in the rest of the paper.